everyone. My name is Khaled M.M. Alrantisi and I'm from Com 22. Today I am happy to present my thesis and my diploma project, which is called Denial of Service Attack Detection using Autoencoder and Ensemble Learning. You can find this one in preprint here. And this work was done under the supervision of Mr. Mohammad Imtiyaz Gulbarga, is the coordinator of the Cybersecurity Center. This is at Alato International University Faculty of Engineering and Informatics in Bishkek. So let's begin. Uh, but before I talk about the problem and the value proposition, I want to let you know what is my project about. It is about protecting networks from DoS attack. Let me explain what a DoS attack is. DoS means denial of service. It happens when someone sends thousands or millions of fake requests to a website, server, or network, and because of this, the real users cannot use the website. It becomes very slow or completely stops. Uh, this causes big problem for companies, banks, hospitals, and government. Sometimes attackers do this to break systems or to ask for money. My project solved the problem with artificial intelligence, and I built a smart system that uses an autoencoder, and the autoencoder learns what normal internet traffic look like. Then three different classifiers work together, which is random forest, k-nearest neighbors, and support vector machine. These three programs look at the data and vote. If most of them say this is an attack, then the system says attack. This makes my system very accurate, more than 99% correct. It gives very few wrong alarms, and it can even find new attacks that old systems miss. So this is my project, a better and smarter way to detect DOS attack. So we are going to talk about the problem and value proposition. So let's see the problem clearly here. DOS attacks are very dangerous today. They stop websites, online shops, and important service. And all tools like Snark, Zeek, and Suricata are rule-based. They can only find attacks that are already known, but new attacks come every day, and these tools miss them. So also they make many false alarms. They say attack when it is not an attack. So this makes security work very hard, and my solution is much better. I use the AI, which is an auto encoder to learn normal traffic plus three classifiers that put together. It finds more than 99% of attacks, and it has very few false alarms, and it works even on new unknown attacks, and this is the big value of my work. So we're going to go to slide number 3, which is the global goal and project plan. My one big goal was clear. It was building a fast and accurate AI system to detect DOS attack in real time. To reach this goal, I worked for 15 weeks with a clear plan. From week 1 to 3, I read many research papers and learned about the topic. From week 4 to 6, I prepared the data and cleaned it and fixed the problem. From week 7 to 10, I built and trained the model. From week 11 to 13, I tested it many times and made it better. And from week 14 to 15, I wrote my thesis and published a preprint. Everything went according to the plan, and I'm happy with the result. So we're going to go now to slide number 4, which is close analyze and literature review. Let's look at what other people did. Many tools like Snort, Zeek, and Suricata are all styled tools, and they use rules to find attacks, but they cannot catch new or unknown attack. In research, there are three good papers that is talking about it, and it's you can see them here, and there is they are the three top research articles that have been made to do the project, but no one before combining an autoencoder with an ensemble of classifiers, especially the OS attack. This is a new and important part of my work, so I filled this research gap. And now let's go to slide number five. You're talking about here uh, methods, approaches, tools, and frameworks. I will explain how I did it step by step. First, I used the NSL KDD dataset. It is a standard dataset with a normal traffic and many types of attack. First step, I cleaned the data and removed uh, the values and balanced it. The second step, I used the recursive feature elimination, which is an abbreviation to three letters RFE to choose the best features. Then I built an autoencoder with TensorFlow and Keras. The autoencoder learns uh, only the normal traffic patterns. When it sees normal traffic, it rebuilds it well. But when it sees an attack, the rebuild is bad. This shows something is wrong. So after the encoder, I took the important features it's learned and give them to the three classified which I purposely mentioned that are called random forest, k-nearest neighbors, support vector machine. K nearest neighbors is KNN and support vector machine is SVM. Finally, the three classifiers work together. It, if two or three says attack, the system says attack. I did all this work with the Python Google Colab. I used TensorFlow and Keras for the autoencoder and scikit learn for the classifier. So we're going to go to slide number six. As you can see here, uh, the results and referring. The results are very good. My model achieved more than 99 accuracy or in the test data. It also has a very low false alarm rate, much better than other system. All the details, numbers, and the graphs here are in my preprint paper, which you can see in this website here. And I built this one, this important reference. You can see the reference here. All of the references can be seen in my preprint, and this is the end of my presentation. And I hope you enjoyed watching this video. And thank you very much for listening and for your attention. I hope you have a wonderful day. Thank you.